Okay, we are going to continue on with a mini radicals unit. So the reason we are doing this is because in Unit 7 you're going to need to use radicals. And you are going to need to know how to reduce radicals on your own without the use of a calculator. You need to know it for that unit. You also need to know it for ACT if you ever take the SAT and other standardized tests. Okay? So during this unit, there is no use of a calculator. Okay? So mini radicals unit. Here we go. So first we're going to start off with reducing radicals and how to reduce radicals. We did talk about this briefly already. We're going to talk about it again. So one way to do it is to find the largest square number. Remember square numbers, like 1 is a perfect square, 4 is 9, 16, 25, 36, 49, so on, right? Because 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. So one way to do it is to find the largest perfect square number that goes into it. So like 27 can be broken down into 9 times 3. 9 is the largest perfect square, okay? The square root of 9 is 3. So what happens to that is it comes out of the radical because we take the square root of it. We bring the other 2 that's already outside the radical down. The 3 that I cannot take the square root of comes down and it stays inside the radical. I go ahead and I multiply anything on the outside. And if I had multiple things on the inside, I'd multiply those also. So 2 times 3 is 6. So 6 is now on the outside and we have 3 on the inside. So the answer is 6 square roots of 3. It is a reduced answer. It is not a number answer without a radical. The reason being is because if I would actually put this into my calculator, 2 square roots of 27, it's going to give me some really funky decimal. That's not terminating, meaning the decimal doesn't ever end, and it's not repeating. So it's this funky number decimal. So instead of rounding it, we put this reduced answer in, and that's the most accurate answer. A way that I prefer to do it is actually finding the prime factorization of the number. So for instance, I have 2 square roots of 27. To do the prime factorization of a number, so prime factorization is the last line where all the numbers multiply to equal, in this case 27, but all those numbers are prime, so we can't reduce them down at all. So I just figure out, okay, what times what equals 27? In this case, I know 3 times 9 equals 27. Then I keep reducing this down or keep breaking it down until they're all prime numbers. 9 is not prime because 3 times 3 equals 9. What I cannot forget to do is bring down any other numbers that are with it. So now 3 is prime, 3 is prime, and 3 is prime. So this is the prime factorization of 27. What I do then is I circle any pairs of numbers. So I have a pair of 3s here. Since I have a pair, we take one out. Because what is 3 times 3? That's 9, right? The square root of 9 is 3. So 3 comes out. So anytime you have a pair, one of them comes out. It's gone on the inside. I bring down what I had on the outside. And anything that did not have a pair stays on the inside. So that would be 3. 3 times 2 is 6 square roots of 3. And that would be your answer on that guy. All right, so I want you to flip to this page. This is page 3. Some of these are numbered and some of them are not. Okay, so break down 32. 32 breaks down into 8 times 4. 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. 4 is not prime, so I'm going to break it down more. So that breaks down into 2 times 2. I bring down this 2. I bring down this 2, and I bring down this 2. I have a pair of 2s, and I have another pair of 2s. So what happens is one of these 2s from that pair comes out, and that's gone. One of these 2s from that pair comes out, that's gone. What is left over is what doesn't have a pair, which would be square root of 2. I actually multiply those two things, and I get 4 square roots of 2. Again, the reason I take out 1 is because 2 times 2 is 4, square root of 4 is 2. If you wanted to do it the faster way, 32 breaks down into 16 times 2. 16 is the largest square number that goes into 32. Square root of 16 is 4, and I have that 2 left over, so here is my answer. All right, breaking down 20. 20 breaks down into 4 times 5. 4 breaks down into 2 times 2, and then I'm going to bring down that 5. I have a pair of 2s. One of those 2s comes out. The 5 stays in. Okay? Go ahead and pause me and try 3, 5, and 8 on your own. 3, 5, and 8. Unpause me when you're done. I'm going to quickly go through these because you should have just tried them. So that breaks down to 7 times 4. This breaks down to 2 times 2. Bring my 7 down. I have a pair of 2's, right? So 2 comes out, square roots of 7. 54 breaks down into 9 times 6. 9 breaks down into 3 times 3. 6 breaks down into 3 times 2. I have a pair of 3's. So 3 comes out. That's gone. Square root of 3 and 2 are on the inside. I go ahead and multiply those back, and that is 6. 108, I know 4 goes into that. It's 4 times 25 is 100, so 4 times 27 would be 108. 4 breaks down into 2 times 2. 27 breaks into 9 and 3. Bring this 2 down. Bring this 2 down. 9 breaks down into 3 times 3. Bring this 3 down. I have a pair of 3's and I have a pair of 2's. So a 2 comes out, a 3 comes out, and I multiply those. 2 times 3 is 6. Square roots of 3. Number 4. The only reason I didn't have you guys do this before is we did this one as our first attempt, but I want to talk about this number out front, right? So I break 27 down into 9 times 3. So I'm going to take the inside and do the same things. I break 9 down into 3 times 3, bring down this 3. I have a pair of 3's, right? Well, 4 is already on the outside, so 4 stays on the outside. One of these 3's comes to the outside, and that's gone now. And I'm left with this 3 on the inside. And then I actually multiply those. So I get 12 square roots of 3. Go ahead and do 6, 7, and 9 real quick. So pause me, try those 3, unpause me when you are done. Okay. 90 breaks down into 9 times 10. 9 is 3 times 3. 10 is 5 times 2. I have a pair of 3's. So a 3 comes out to multiply to the negative 5, so I get negative 15. Square roots of this 5 times the 2 is 10. 98 breaks down to 49 times 2. 49 breaks down to 7 times 7. Bring down this 2. I have a pair of 7's. 7 comes out to multiply to the 2, so I get 14 on the outside, square roots of 2. 96 breaks down into, I think 6 goes into that 16 times. 6 breaks down to 3 times 2. 16 breaks down into 4 times 4. I'm actually going to stop there, even though it's not the prime factorization, but I have a pair here, and these two are prime. So I'm going to go ahead and take that out. So I'm actually doing 3/4 times 4, square root of 3 times 2. Okay? That's the same thing as doing 3/4 of 4. Well, 3/4 of 4 is 3. Square roots of 6. Okay? For right now, go ahead and skip 10 through 15 and go to the next page, page 4. Because now we're going to talk about variables. So variables. We're still going to break the number down the same way we were, so I'm going to break that down to 3 times 3. And then I'm going to list out what this means. X squared means x times x. I'm going to circle my pair, so I have a pair of 3's and I have a pair of x's. So 3 comes out, that's gone. This has a pair, so one of those comes out and it's gone. I have nothing left in the radical, so actually on this guy, 3x is my answer. Same thing here. That's 6 times 6, and I have y, 2, 3, 4 of those y's, so I have a pair of y's. I have another pair of y's, and I have a pair of 6. So 6 comes out, that's gone. Y comes out, that's gone, and another y comes out, and that's gone. There's nothing left in the radical, but I need to reduce that to 6y squared. I'm going to skip this one. I'm going to go to 19. This just means x times x times x times x times x. I have 2 pairs of x's. So an x and an x come out, and I'm left with a square root of x inside. So really I have x squared square root of x is my answer. Pause me, and I want you to try 18, 20, 21, and go ahead and try 23 for me. Unpause me when you are finished. All right, on 18, the square root of 64 is 8. I have 6 c's, so how many pairs would I have in 6 c's? I would have 3 pairs, so that would be c to the 3rd, and then there's nothing left. C to the 13th, I have 6 pairs in c to the 13th, so I have 6 pairs of c's, but then there would be 1 left over, so to do that, that would be c to the 6th, square roots of c. Here, square root of 16 is 4. Square root of x to the 4th is x squared, because I have 2 pairs. Square root of y squared would be just y, because I have 1 pair of y's. And then square root of z to the 8th would be z to the 4th, because I have 4 pairs in 8. 23, We have a fraction, but don't let that scare you at all because it's the same thing. All I need to do is take the square root of 25, which is 5. Take the square root of 36, which is 6. So really, that's just 5/6. There's nothing left in the radical after you take that. Square root of x squared is just x. Square root of y to the 8th is y to the 4th. Let's look at let's look at 26. Break down 50 into 25 times 2. 25 breaks down into 5 times 5. Bring down my 2. I have a pair of 5. So on the outside, I have 3/5 times 5. I have 1, 2, 3, 4 x's, so that's 2 pairs, so that would be x squared. What I have left in the radical would be this 2. So now I need to reduce all that. 3/5 of 5 is just 3. I have the x squared out there, square roots of 2. Okay, what I want for you to do is on page 3, we did not do 10 through 15. So I need for you to do 10 through 15. And we did not do 22 through 30. I need for you to do 22 through 30. I'm going to put my answer key to those into Schoology. So once you've done that, I want you to check with my answer key. And then I want for you to complete the assignment in Schoology that goes along with